Well, good morning all and welcome to the June Air and Space Power Seminar. I'm really excited to host today's seminar with Dr. Heather Roff, all the way from Phoenix, Arizona, and I think she said it was about 150 degrees, so a little bit cooler over here in Australia. Look, about 12 months ago, I think it was, I was watching a show on SBS called Cyber War, and they were talking about artificial intelligence, and I saw Dr. Roff talking about some of the ethical considerations. And I thought the way that she spoke and presented and had that moral courage to question our pathway down AI and the rise of was really, it spoke to me. So being a not so young upstart, I jumped online, stalked her through LinkedIn and asked the question if she'd be willing to present. And here we are. She said yes. So it's really exciting to have you on board and have this idea realized. Dr. Roff has previously been a fellow in foreign policy at the Brookings Institution and an associate fellow at the, if I get this right, Leverhulme Center of the Future of Intelligence. She was a research scientist at DeepMind in the Ethics and Society team, as well as a fellow at the New American Foundation on the National Cybersecurity Initiative and Future of War Project. She holds PhD in political science from the University of Colorado, an MA in political science from the University of Wisconsin-Milwaukee, and a BA in political science and classics from the University of Arizona. So that's pretty impressive CV just there. Her research institutes include law, policy, ethics of emerging military technologies such as autonomous weapons, artificial intelligence, robotics, and cyber, as well as international security and human rights. So before I do hand over to Dr. Roff for her presentation, I need to be clear that despite her amazing credentials, she's talking to us today in a personal and private capacity, and her views, comments should not be taken as or attributed to previous employment or as any other confirmation. So before I do head off, don't forget to add your questions and comments down in the Q&A area, and we'll pose those questions to Dr. Roff in due course. But I think that's enough from me. Dr. Roff, handing over.
Thank you. Thank you so much, Theron. Thank you, everybody, for joining us today. It's a pleasure to speak to you. I love my Australian colleagues. I spend a lot of time speaking with them in the Department of Defense, and I've spent some time in Canberra, so this is a treat. So yes, I'm still a fellow in foreign policy at Brookings and at the Leverhulme Center for the Future of Intelligence. Yeah, these are my personal and private capacity comments. So feel free also to find me online if you have any questions and they were not answered today. I'm usually pretty good at getting back to you either via LinkedIn or Twitter or anything else. So let's get started. So human-machine teaming. One of the drivers for this project and what I'm going to say today comes out of my work on autonomy. And I've been working on autonomous systems and the ethics of autonomous systems and policy and law for about 10 years. I've spoken several times to the state members at the United Nations Convention on Conventional Weapons. I've also been the special governmental expert for the DoD and was their primary author for the Defense Innovation Board's AI ethics principles that the Department of Defense signed into effect in February of 2020. And so through that work, through my work on autonomy and my work on AI, one of the kind of constant drum beats is that, well, there'll never be full autonomy, and the way in which we design systems, there's always a human somewhere, and so it's really better thought of as a human-machine team. And this piques my interest in various ways, and so I hadn't had a lot of time to start thinking about it. And so as I've started to have more time to think about it, I really started seeing such wide variation in the literature and wide variation, if any, very little policy, and what policy there is, quite a bit of variation amongst that. And so I think there are some serious challenges as well as some pretty good opportunities coming forward as we are pushing more into this human-machine teaming paradigm, or manned-unmanned teaming paradigm, if that's your nom de jour, or human autonomy teaming. There's all of these names kind of flying around, whether we're talking about, what degree or kind of machine we're talking about, of automation versus autonomy. So there's all these different kind of unresolved issues that I think need better clarity. So that's kind of what this talk today is going to be about. This talk today is going to look at some of these, some ways in which we can bring a little clarity to the debate. And then hopefully through that clarity, we can then start to think about how to influence and shape policy or even norms or language or focus attention on research and development going forward. So what is human machine teaming? Well, one of the funny things is that I'm also a philosopher. So being a philosopher, I can't help but think that Wittgenstein is really appropriate here. So when we think what is human machine teaming, everybody seems to come to the party with a different assumption of what that party is going to be like. And so, Wittgenstein says, language sets everyone the same traps. It's an immense network of easily accessible wrong turns. And so we watch one man after another walking down the same paths, and we know in advance where he'll branch off, where he walks straight on without noticing the side turning, et cetera, et cetera. What I have to do then, I being Wittgenstein, is then erect signposts at the junctions where all the wrong turning so as to help people pass the danger points. The thing about what Wittgenstein is saying here is that language can play these tricks on us, and the way in which we come to words and what we understand through words, and even the differences when we speak the same language. So from Australia to the United States to Canada to the United Kingdom, we have wide variation in our terms of what we feel is appropriate or what we mean by this thing or that thing. And so when we come to more difficult or ambiguous concepts like human machine teaming or autonomy or AI, the goalposts continue to shift, and everybody's coming to the party with their own kind of assumption of where that path should be, or that everybody's on that same path. So my idea here is to just not say, I'm going to give you the one definition, right? I'm not going to say, here's the one definition, silver bullet, this is what's going to do it, this is what human machine teaming is. It's too early in the game for that. But what we can do is we can, through, I think, some decent analysis, go through what has gone before and start to present a taxonomy of where some of these danger points are, right? That Wittgenstein says that we need to signpost for, so that we can kind of sidestep things that we don't want, and then turn down those paths that we do. So what's the problem? Okay, well, right now, when you think about human machine teaming, or if you're in the human machine teaming space, right, this is so broad. It includes so many different aspects for not just designers, but just how one even starts to construct the problem and the problem space, right? We have, obviously, a lot of people draw attention to robotics. We have a lot of interest in cognitive science and social, and to some extent, I would say social and behavioral sciences. That's certainly getting more attention as DARPA has started to put some attention towards that. Typically, we're looking at human factors and human systems integration and user design, UX design. That can be adaptive UIs, that can be just straight up user interfaces, things like that. But HMT, for the most part, kind of sits in the middle of all of these things, right? And so it's really hard to say what exactly it is and what problem we're looking at until we have the widget, right? We're looking at a 30,000 foot level, and we're not looking down at the kind of tactical level, the widget level, and saying, well, this widget is a robot, is not a robot. Is the cyber physical system, is not a cyber physical system, it's a non-physical system, it's a decision aid or something like this. It requires traditional human factors analysis of bodily movement, how many G's a pilot can take, what their G suits need to be engineered to be, along with user interface design and helmet design and pop-up displays and heads up. We understand a lot of that, but when it comes to this other type of the cognitive side of things, we are really kind of still in some pretty early territory. And so cognitive science is becoming much more important and at the forefront. However, even cognitive task analysis, while it does have a decent pedigree, is really hard to do rapidly and at scale and in any sort of systematic way for the wide variety of applications that, say, modern militaries want to use human machine teaming for, or what even counts as a human machine team. That's a whole antecedent question. So if we say, what's the problem? Where is HMT? Well, it sort of sits in the middle of all of these. However, what's missing? Well, a lot, right? It's not just kind of the same old handmaidens of, robotics and cog-sci and AI and computer science, right? Actually, there's a whole host of other things that we have to take into consideration to understand HMT, I think, at a more granular level. And that organizational behavior, right? That's a huge one. Cybersecurity, obviously. Network design and architectures play a huge thing, but also, and I think less appreciated, are things like linguistics and philosophy and law, policy, the humanities generally, anthropology, neurology, psychology and psychiatry, and on we can go, because the thing is that this is a human and a machine teaming. And so we really have to take into consideration not just the design and the development of the machine, but really the human as well. And the human becomes sort of their own, they become black boxed in, right? We just say it's a human, and we assume what we know all humans will do in situation X or Y. And that may not, in fact, be true, especially as we go forward with plans to create adaptive systems, so that each system may adapt to a particular human user. And so if that's true, then baselines and benchmarks and metrics become really, really important. And we have to at least have some sort of way of understanding what that looks like along so many different axes. So basically, someone might say, so what? Yeah, words matter. Big deal, Heather. Who cares? Well, the thing is that how we define things really does matter. It's not just for pontificating. It's not just, navel gazing for us and political theorists, but it really does matter. So it does matter conceptually, right? For me and my ilk, the navel gazers, we like to think, well, whatever I define it as draws these boundaries. It draws boundary areas around what I can include within the circle, what I exclude outside of that circle, what I privilege within the circle, what I prioritize, in some maybe lexical ordering, what ultimately I can give power to, or whom I give power to. And all of that is included in a definition. The language which even supports that definition is loaded in a variety of ways. And that's just on the conceptual side. Practically, right? And many people here are like, yeah, that's interesting, but so what? Practically, that really matters too. Boundaries matter too. I mean, you can think of scoping for just small projects, right? Or large projects. Technically, we need to scope. We need to write requirements. We need to write testing plans, we need to have estimations for evaluation. We need to have metrics. We need to do verification and validation on systems. We need to understand what right looks like, what off-label use looks like, what certification processes we need, what licensure might happen. All of those are practical matters that are highly, highly relevant and are going to be bound up in the definition. And they're also going to matter programmatically. So for big, large militaries, right, acquisitions is not a small problem area. At least in the United States, acquisitions is facing many, many challenges, especially with AI and emerging autonomy and things like this. And so programmatically, a program manager is going to need to know what the budget, cost, and schedule looks like, what milestones one has to meet. And all of that is going to be considered as, this is a human machine team. This is what's included in it. This is how I measure it. This is how I estimate when I can test and when it succeeds and when it doesn't succeed. This is what risk looks like. This is what over budget might be. So all of these things matter in the scoping for practical purposes. It also matters practically outside of the kind of technical design development acquire side of the house to the R&D side of the house and the scientific progress side of the house. Because even the way in which we talk about human machine teaming, we can kind of privilege what we are emphasizing. Well, we can emphasize different things, right? So if you think of whether I'm talking about human machine teaming, or I'm thinking more really about human machine teaming, or I'm talking about human machine teaming, right? Like where that emphasis is placed really does start to matter. So if I think that the human is first and foremost, because human comes first, then I'm going to start thinking again, maybe back to that cognitive science and psychiatry and psychology, behavioral science, anthropology, like how humans interact in certain types of cultures or in certain types of organizations, what roles and responsibilities, how those nonverbal cues in exchange of language, all of that is going to start to matter in the design. So this gets really into that user-centered design side of the house, but it's really about focusing on the human. When we think about human machine teaming, well, then what we're doing is we're really thinking like, how do I have to build this system? Whatever the human is, the human's just, you know, a flesh bag with a nice little noggin on top, and the human will learn. But it's the machine engineering, it's the widget that matters. And that will also shift our attention down a particular path, right? What we start to privilege and prioritize. You know, are we prioritizing the hardware, the platforms, the networks? Are we prioritizing the AI? And what about the AI, right? What kind of AI is it? What types of safeties and safeguards do I need? Is it an online learning system? Is it a supervised learning system? Is it a, you know, frozen one with like a guardian or a watchdog on it? There's all sorts of different types of things that we would get bound up and concerned about when we're thinking merely about the machine side of it. And then if we think about the human machine team, and we're really privileging teaming, then we have to understand how humans and machine, like what makes the team, right? And is the human and the machine team different in some way than prior types of teams? And I say this because through the literature, you will see, if you do a lot of work here, that you will see a lot of privileging. And, you know, I'm not saying that it's because humans are amazing and that we should. I think most of the time it's for ease and cost and time. But there's a lot of privileging and analogizing of human to human teams, and that's what's good for human machine teams. For human teams to be considered successful, they must operate along these indices, or we must be able to measure, you know, efficiency at this rate, or communication through these types of channels, whatever that looks like, whatever the widget's going to be. But the human privileging and the human analogizing to human machine teamings may not actually be appropriate, right? And so even thinking about different forms of analogy, something maybe like human animal teams, handlers, for instance, those are teams. And so, you know, you can think of things like that, like, well, here you might have this intelligent agent that's doesn't think like a human, may not perceive like a human. But we have figured out in years past how to measure certain types of qualities and performance metrics that we want to see through that type of team. But even in that, there's going to be some ill-fitting analogizing, and we have to be very cognizant of that. But as you can see, even in the scientific progress side of the house, whatever we're privileging in human machine teaming actually starts to matter in the way in which we design and we develop and we deploy such systems and we evaluate such systems, as well as how we evaluate humans in that way. And so what we do here, right, is basically when I start to write things down and I say, this is the requirement, and here's the money, and here's what I'm going to measure, and here's what I'm not going to measure, here's what I think is right or not right, all of that impacts ultimately what we consider valid. And that is something that I don't think we should take quite so faithfully just yet. So that's a very less eloquent way of saying it. But so what's one way to do this? I basically said everything stinks till now. So what's one way we can do this? Well, we can do something that I've been, you can follow my lead or not, but I've been trying to think about a way of creating a taxonomy around human machine teaming. Because right now it is quite premature to just offer that single bullet definition, but because each way of thinking about it has benefits and it has costs. And so we might want to identify those benefits and costs and fit to purpose, right? Fit what we mean to purpose. So through an extensive literature review, an extensive policy review, an extensive SME, subject matter expert review, and a lot of interviews, one of the things in which I found very common themes is that definitions tended to fall along these three categories. And the way in which I've created these categories is thinking about how does the definition, what is the definition privilege, right? What is the biggest thing that, the definition draws attention to? Oftentimes, elements of these get kind of globbed in, but what is the primary feature? So you can see in some, academic labs that focus on human-machine teaming, or you can see in some more aspirational documents like the U.S. Air Force Research Lab, AFRL. There's others. MITRE to some extent has some of this. There's a lot of there's some definitions that kind of talk about HMT as a field of study. And this is really kind of the academic literature, and we might say we don't really care about how the academics define it, but we do, and we need to, because that's where a lot of some of the cutting edge research, or the basic research in the US, the color of money is 6.1 to 6.3. That research really does come out of academic labs. And so how we think about HMT there does matter. So if we think of HMT as a field of study, then we would say, I look at this definition, I categorize it this way. It's really privileging HMT as a field of study, or a combination of interdisciplinary areas, right? That's that Venn diagram that I showed you more early on. And so you can say, okay, that's how I see HMT. It's kind of this big Venn diagram. And by the way, PowerPoint won't let me put more than like 7 things on the Venn diagram. So I could have put many more, but then I think it would have just looked like a blob. So, okay, so we have field of study. The second we have is a property, a feature, or a function. And these types of definitions really identify and or privilege various properties, elements, features, or functions of an HMT. And more often than not, again, they kind of generalize to humans, and then they focus on specific tasks or functions for the machine. Now, obviously, human-machine teams can be quite varied, and I'm not proposing that I can solve all the different combinations or applications thereof today or tomorrow or even ever. And so what we can say is that, look, there's no kind of one way to pinpoint this is an HMT application, this is not at this stage, because we have to make some assumptions and we have to make some commitments. But what we can say here is that when we're talking about a property, a feature, or a function, it's the qualities that these systems and the team itself has that really matters. Oftentimes you'll see a lot of these definitions are premised on what's called the MABA model, which is men are better at, machines are better at model. And so you'll say like, well, humans are really better at, men are better at, I know men, but men are better at, adaptation, generalizability, one-shot learning. They can look at one thing and they can analogize another thing. They can learn concepts. They are very flexible and adaptive, and they can, really learn from new experiences on the fly. Machines are not good at any of those things. What machines are better at are, large pattern recognition, computation, big data, things like that, right? And so we hear that all the time. If we could just pair that, generalized human intelligence with the access to all of this data, and the ability to compute so quickly and find these patterns and to be able to do probabilistic predictions, we're gonna have the superior capabilities of both. And in some domains that is true, in others maybe not. But we have to be kind of careful when we're automatically assuming machines are better at X and men are better at Y. There may come a point in time where machines are better at X and men are better at Y. Like there's different ways in which that combination can go, and the assumption needs to be rebutted. It's actually a presumption. It needs to be rebutted and not taken as gospel. So the property, feature, or function one is often premised by these types of arguments or platitudes around the MABA model. So again, in a lot of these definitions, you'll see things like systems, not talking about humans and machines specifically, but often privileging machines. Systems need to be adaptable, flexible, directable, transparent, observable, and trustworthy. Trustworthy really comes into the fray here, and then how we create trust or engender trust, human trust of machine partners. And that has its own huge swath of literature. But those really look at properties, features, or functions for the definition. The third way of talking about HMTs is a relational one. And this one I find to be really, really interesting from a scientific as well as a conceptual standpoint, right? I can look at properties and I can features or functions, and I can understand a field of study. But the relational one is really, really quite puzzling in some ways. So relational definitions really emphasize the importance of the kind and the form of connection or association between the human and the machine teammates. So things like possession of a common goal, pursuit of a common goal. So possession and pursuit are different, right? Like I can be pursuing something without really having awareness of it. I can even pursue something kind of not even being aware, but I might not even have self-awareness. I'm just pursuing something because I've been, it's a machine that's been optimized to do so. But possession of a common goal is quite different than pursuit. Having or sharing intent, right? You might have to have intent to then share intent, which is a whole nother discussion in the philosophy of mind, but shared intent. They might have to be cooperative, right? And cooperation here has a lot of interesting elements to it. And so the relational definitions talk about this in this kind of very joint, common, cooperative element. And it's the relation between the humans and the machines that are privileged. So we have these kind of three buckets that we can kind of, when reading a document, a policy document, when reading an academic article, when looking for scientific endeavor, right? You can pretty much slate almost every single article into either we're talking about a field of study, we're talking about a property, a feature, or function, or we're talking about something having to do with relational. Okay, so where's the rub? Great, I have these three buckets, now what do I do with them? Well, when we talk about a field of study, right, the pros from a recovering academics perspective, it helps to prioritize funding and attention and focus. It can attract talent, new grad students, new emerging areas, new applications. And it can narrow the field so that we can kind of create a competitive atmosphere to get the best and the brightest minds. That's great, right? I get a lot of money. I can support the lab. I can create all these great widgets, and that's wonderful. What's the con? Well, HMT is still way too broad, and it often ignores, either explicitly or more often than not implicitly, some disciplines over the others, and it creates power hierarchies that we might want to shy away from. On the property, feature, or function side of the house, the pros, right? Well, the property, feature, or function definition, the pros, right? It scopes. It does a great job of scoping. It scopes designers and engineers and program managers. It even scopes for commanders and operators, what the widget needs to be and what the capability of the team with the widgets need to do, right? What are the mission sets that this widget needs to accomplish? It has to have these features. I can start to write requirements. I can say it needs these sensors and these comm networks, and the humans have to be able to do this with this type of training, right? We can start to really scope in a meaningful way when we're talking about properties, features, or functions. The cons, well, it's rather static, right? When we think about human-machine teams as, if we're defining all of human-machine teaming, according to properties, features, we become kind of time-bound and technology-bound in a particular way of viewing technology. And we know from lots and lots of years of experience that sometimes we're quite surprised where technology goes. And so I think that's, we don't want to be completely hamstrung and path dependent. And then we also don't want to find ourselves being in a sunk cost fallacy, right? Where I've been pursuing, say, one type of capability with artificial intelligence for years and years and years, and I've dumped so much money in it, but yet I just can't get there. Autonomous cars. And you know, it's one of those things where it's like, no, we're gonna get there, we're gonna get there. And so I think that type of, between the static nature of the technology and the types of qualities or features, as well as the sunk cost fallacy, becomes a real con. And and the knowledge about what we know may also be quite incorrect. And this type of definition, as again, obviously and oftentimes focuses not only on the machine, or only on the machine, and not the system as a whole. Okay, so what about the rub with the relational definition? Well, the pros: it looks at some elements of teaming. Great. The cons: it looks at some elements of teaming. So again, where our focus is tends to matter. And I'm going to spend my time kind of going through what I mean by relational, and provide like a subtaxonomy of that for you guys to show what I mean. So here's another kind of quibble I have about some of the relational definitions. And this is a philosopher's quibble, but it has real practical import. So what's a team? Or rather, how am I included in a team? This is actually really important, because if we do start to use human analogies of what good teams look like by looking to organizational and behavioral literature around human teams, which there is plenty, we assume a lot. We assume so much that we may not be able to assume when it comes to the human and the machine teaming. So how am I included in a team? Well, one of the ways that again becomes assumed in a lot of these definitions is about membership. We talk about teammates, but we also use often the phrase team members. And once we note the word member, then we have to say, well, how did I become a member, right? How did I become a member of this team? And that gets at questions around the shared pursuits of a common goal, the possession of a common goal, shared intent. I mean, we can talk about situational awareness. That's definitely a problem, but like, how did I become a member? Not whether or not I'm aware of my other teammate. What's the antecedent to that? And so oftentimes, at least in human teams, right, consent is a huge element to that, right? And there's three fundamental tenets of consent. It has to be voluntary, that is, it's not coerced. It has to be intentional, that is not accidental. I can't just be like, oh, I showed up here and I guess I'm going to pay dues at this ship. It has to be intentional, and it has to be informed. I have to know what I'm signing up for. So I can't be thrown in the back of a car, over to a gym, accidentally walk into the gym, told I'm a member, right? And then have somehow not been aware that they're going to take my house membership dues, right? Like, we have to have those elements: voluntary, intentional, and informed. Oftentimes, though, at least in military domains, not all of our membership is fully consensual, right? We might have had some prior form of consent, but later acts of consent maybe didn't happen. You're assigned to a billet, you're going to do this thing, here's your training, go. I'm not going to get into that here. I'm just going to say there's a problem there, and we need to think about how that impacts team cohesion and all that other stuff. So consent, that's a huge one. Role responsibilities. The other way in which I become members is that maybe I have some sort of role and set of obligations that come with that role. You can ask me about this in Q&A. There's a really interesting set of discussions about this in moral obligations based on roles. Gratitude, right? Gratitude is also sometimes an off-cited ground of obligation. So if I'm a group, or if I've received some benefit, so maybe, you know, look, I'm trying to think of something that's not warlike, you know, oh, in the US, I don't know if you have it in Australia, but in the US, for instance, my mother got one the other day where somebody sent her a big packet of return address labels, you know, for the ASPCA, and you know, look at what we've given you. We've given you free address labels. Don't you want to spend, you know, send us $20 and become a member of the ASPCA? This is some sort of weak form of weak sauce, as we call it in my house, weak sauce attempt at creating a form of obligation based on gratitude. even though it's not really like, oh, thank you for the labels, but whatever. The other one too is fair play, right? Fair play is like, well, if I do this and you do that and you don't play, you don't give your fair share. So this is kind of a free riding problem that you have a grant of obligation. And so membership, and this can, fair play and gratitude also play big roles for those interested in theories of political obligations, of why I pay my taxes and obey the law. But gratitude and fair play, role, responsibilities, consent, all of these really have something to do with membership. And it seems rather odd when we're talking about teams and members of teams that any of these things would play a role in their standing as a member. So membership for machines is a bit weird, but that is, I think, one of the anthropomorphic artifacts of not just the notion of a team, but the way in which we've been analogizing human machine teaming to human human teams. And maybe that analogy is really not good and quite ill-fitting. So we should just leave it at the door. Okay. Off my soapbox on that one. So what are the elements that we can look at for relational HMT? And I should note too that the relational HMT definitions are by far the most common in big long-term strategies, right? So if you look around at US military or Australian or NATO, you look around at lots of different, the UK has recently Joint Concept Note 18. You look at a lot of the think tank stuff, you look at a lot of the horizon scanning documents, what you'll see is relational definitions of HMT. And these, I should note, from a technology's perspective, these are completely aspirational definitions, right? These types of systems do not exist. We do not have AI systems that can understand concepts. It's a pretty strong lift to say that they have intention. They're pretty much idiot savants right now. So they're not that smart. They're highly good at one thing, and outside of that, they're incredibly dumb. And so, a lot of the different discussions we have about relational aspects of human-machine teams, focusing on machines here, these are aspirational definitions. And the very nature and the very fact that they're aspirational means that we don't have policy about how to guide them. And we really don't have any laws, nationally or internationally, about what is, what can or cannot be done, or what risks should or should not be taken, and what negligence looks like, and all of that stuff. Those are gone, because what we're talking about are these aspirational systems that we want to build. So that's something really important to note just at the outset. So, okay, we know that they're aspirational. We know that they don't yet exist in this form. Okay, so what would we be talking about then? We're talking about a relational HMT, the form, kind, and content of the relationship between the humans and the machines. Okay, well, we can do it in a kind of decision tree. And I take my inspiration here from moral philosophy and kind of the taxonomies that we create in that space. It's kind of a logic-based approach. Okay, so we say we're going to start with relational definitions. Well, there's two kinds of relations we can talk about here. One is that, the relationships are kind of ends driven. That is, they're teleological. So teleological here would be the relationship is for some end, right? In the military space, we could say the relationship, the human machine team, is for some mission. It must accomplish X, right? It has some goal, some end, some purpose. The other kind of relationship we might be talking about here is one based on status and one's obligations to each other based on one's status. And those are deontic relationships, right? So you might say, I have a human right to X and you have a duty not to interfere with that right. I'm not going to talk about deontic status in relations of HMT, because I'm not going to grant robots or AI's rights in any time soon. So if ever. So we're just going to put it there just for classification purposes. But we can just say, for the sake of argument and clarity, we can have teleological and deontic types of relations. Okay, so in the teleological one, which is obviously the most off-sided, right? It's for a pursuit of a common goal, all of these things. We can then further subdivide into, well, what kind of end or goal is it, right? And if it's we can say, well, it could be an instrumental goal. That is, it's for some specific instrumental good. It's good for me because, or it's good to further X, right? So we say the human machine team of the loyal wingman, for instance, right? We can look at, so I know that since this is the Air and Space Power Center, right? We can look at, say F-35s teaming with autonomous combat unmanned systems. And we're going to have loyal, it's basically loyal wingmen, right? And we can look at maybe the Air Force's Golden Horde kind of concept here. You can say, okay, look, what I really want is I want to have, a human F-35 pilot, quarterbacking, and it's got, it's got a set of 4 ships here and a set of 4 ships there. And they're doing their own thing, but we're all working to achieve some higher order goal for some other higher order goal, right? Win the war, whatever, take the peace, achieve the peace, I should say. So that would be an instrumental kind of goal, right? All of these systems working together as a team is in furtherance of something else. Okay. Non-instrumental, however, would be something more along the lines of it's good in itself, right? Now, many might scoff and say, oh my God, that's silly, we're talking about machines. But hey, man, if we're going to start getting into the types of contextual awareness and the types of cognition required to get to these aspirations of HMT, why not throw it up there? So non-instrumental would be something like in the virtue ethics vein of, you're living your best life. I am doing all of these things in pursuit of the good. So maybe there's an HMT out there that's going to pursue the good, but I'm not going to pursue that here. So we're going to keep going down the other vein. So, okay, so we've got relational, teleological, instrumental. And in the instrumental vein, we can then think of, okay, it's good for some end, something else, right? It can be either adversarial or it can be symbiotic. So that is within the pursuit of that end, right? We can have this symbiosis, right? It's this really cooperative, balanced type of relationship, or it might be combative and adversarial, but it still tends to work, right? I mean, I'm sure you have colleagues that you see and you go, man, I can't help but argue with them about something, but in the end, we get this amazing product. You might see something like that. So not going to talk too much about adversarial here, but it's possible. So, okay, so let's go down the symbiotic line. So then we say, okay, it's a symbiotic cooperative, right? You can think of something like, the little fish that eat algae off of bigger fish, right? It's a symbiotic relationship. Okay, within the symbiotic relationship, you can also have intentional or unintentional or non-intentional. So you could say, look, nature tends to select for certain symbiotic relationships. Yay, but that wasn't, unless you believe in intelligent design, that wasn't done intentionally. So we can think of it that way. Or you can say, no, we're going to intentionally design for this symbiosis. And there's a lot of interesting work that can be done here, but that work is highly, highly relevant on understanding humans a lot better than we understand them now. We do not have a good understanding of the wetware. And we do not have a good understanding, at least even if we start just looking at the wetware, we use pretty crude methods and we use pretty crude metrics. And so fMRIs are not going to be sufficient. Eye tracking and gaze tracking, heart rate, perspiration. These are really, really weak proxies for the things we want to get at. And when it comes to relationships, those are social, behavioral, anthropomorphic types of questions that are really not studied at all in this space. So intentional. And then through here, we can then further subdivide both on the non-intentional / unintentional and the intentional side. We can look at that and say, okay, even here, we can talk about a scale of what we were talking about when we're talking about what the HMT is. And this is really interesting to me. We can talk about mere interactions, right? Or we can talk about joint collective agency. An agency, and I don't have time to get into that today, but agency here really matters for teaming. And so let me back up. So mere interaction might be like, let me give you an example. All of us want to get to work in the morning. We all want to get to work safely in the morning. Maybe we don't want to go to work, we all want to get to work safely in the morning. And so we have this common goal of, I want to live my good life free from somebody else's harm. I'm an Australian citizen. I'm a US citizen. I want to go about my life. Everybody be out of my way. We get in our cars, we drive, we have a set of rules and norms, and that's how we drive to work. Great. Someone comes in front of me, I look at them, they look at me, we wave, we understand what that means. That's a mere interaction. Not exactly teaming, but if we think about the definitions used about pursuit of a common goal, sharing of common pursuits, right? Understanding intent, you can see how the driving example actually would satisfy all of those, but is clearly not what we would think about as teaming. So the definition itself tends to let things in that we might not want to let in. Or maybe we do. Maybe we just draw it that big and say those types of interactions count. Or we might want to say, no, what we really are talking about are these, on the other side of the spectrum, these joint actions, right? Where we're functioning in this kind of holistic joint pursuit. And it's the jointness of the action that really matters. And if it's the jointness of the action, then there's this really interesting phenomenon that's called we agency. And when we look at how humans perform joint actions, psychologically, they tend to feel responsible and have a sense of agency for the group. So you might be playing a basketball game, and the point guard might feel responsible for not doing his or her job, and some other defender or something is but you get my point. The idea here is that one feels this sort of joint moral agency as well as moral responsibility for the actions of the whole and not just the actions of the self. And that's what's called we agency. However, when we're talking about, when we flip that, which is again why I think that the human analogy is really bad, is that the human psychology behind this is basically stating that, as soon as you change one of the entities in that action, even though it's the same action, but the actions being undertaken are being automated through some sort of machine, then the human not only does not feel agency for the whole, it doesn't feel the we agency, the human doesn't even actually tend to feel agency for their own actions, which now we have like a complete loss of agency, which is also really weird and not very good for what we would think of as teaming. So that's just one kind of glimpse of one way you can start thinking about, okay, if we talk about those definitions in a relational sense about the kind and form and content of the relationship, we have to understand the kind of relationship and the qualities in it, and then how we can start to make those things quite explicit, because then that will matter greatly for how we measure, how we provide benchmarks, what we're even going to measure, what our variables are going to be, what our assumptions are going to be, the data that we're going to use. Because the thing about human machine teaming, which I haven't really talked about in this talk, from the ethics perspective, has its own Venn diagram, right? You have this kinds of machine ethics, AI ethics coming into play, but you also have bioethics concerns, and then you have like societal ethical concerns too. And so those tend to put pressure on one another in different ways that we haven't really seen before. If we're just looking at the systems and we're not looking at them as this joint kind of action. Okay, so what do I mean by, there's going to be different pressures even within within the human machine teaming definition paradigm or taxonomy? Well, everybody, I think one of the reasons why we have gotten here is that it really depends on where you stand, right? Where you stand depends on where you sit. And at least for a lot of people in tech, it really depends on how you define what you're going to do, right? What kind of thing you're going to build, what your product's going to be, or at least in the military sphere, what the capability you're pursuing is going to achieve for you. And so all the different types of people in these organizations are going to have a very different viewpoint, and they're going to make very different assumptions about what's important. And so without doing at least a cursory view of stakeholders, from everybody from, project managers and acquisition to lawyers, not just lawyers because we've got acquisitions lawyers, but we also have judge advocate generals, or, the JAG lawyers. We have operators, right? We have commanders. We have all of these different things. We get the R&D folks. We've got the testing community, right? The testing community is going to be seen as the slow moving folks who say no to everything. And the operators are going to be asking for push and capability draw. And of course, there's going to be finance people who are going to say that this is too much money, or what is the sustainment cost going to be? What are the maintenance costs going to be? How are we going to certify a human machine team? How are we going to certify people, let alone the machines? All of these questions are different viewpoints for challenges, but also for opportunities. And there is a serious lack of any real delving into these issues beyond platitudes around, you know, what we need is trust. We need to trust the systems. You know, yes, we do, but maybe the word trust is inappropriate here because, you know, if we're talking about a machine that does not have cognition or moral agency, or even can understand what the concept of a cat is, right? If we can't understand these things, what we might want to do is use more precise language, a la Wittgenstein, and say what we really need to be is confident in the machine's capabilities to X, Y, and Z. And that I would then be confident in using that machine and making judgments about, you know, its predictions or its future actions or its states and things like that. So really, where you stand depends on where you sit, and we need to be much clearer in our language, and we need to make all these things much more clear as we go forward in the human machine teaming paradigm, because we are planning on spending a ton of money in this space. Okay, so what are the gaps? Well, there's a lot. So in policy, not only if we take the relational definition, which is aspirational policy documents, or the strategies and the horizon scanning, right? Within every, you know, even within large organizations, you can say, in the United States, you could say the DoD. Well, the DoD is huge, right? It's the largest employer in the country, 3 million employees, right? How many hundreds of thousands of active duty members? $760 some billion budget, right? And within the DoD, you have countless types of organizations, 5 different services, agencies, field offices, right? All of these things. And so each different organization tends to have its own policies. Some of them are redundant, some of them are not. Some policies are missing. And so understanding the policy space around human machine teaming, once we understand that human machine teaming will impact military standards and how we develop technology to a specific standard, to deployment, to what counts as an HMT and doesn't count, you know, a la autonomous weapons policy in the United States, for instance. So policy has some serious gaps that we need to start to understand. Law, right? It's not just law, ta-da, right? It's national and international law, right? If we're talking about military applications, you know, we're going to have a national law regarding X, Y, and Z, but more to the point, international law, you know, the international law, for instance, on animals in war is pretty minimal, and most of it has to do with like not killing cattle, and so, you know, there's the law is silent here, right? And that means that where the law is silent, all is permitted. And so when we're looking at human machine teams and what that means for, say, international humanitarian law and how we certify and how we license or validate or review those systems is going to be fundamentally different than what we do now on weapons reviews. For instance, Article 36 weapons reviews are not designed now, or even potentially forward thinking, to think about human machine teams as human machine weapon systems, right? We don't have a way of adequately reviewing those right now. And that's a huge gap in law and a huge gap in policy. Military operations, looking at those gaps there. Human machine teaming is going to cut across the entire .milfp enterprise, right? Doctrine, operations, training material, logistics, facilities, right? The whole thing, personnel and policy. Science, there's big gaps in the hard and soft sciences. Pick your science, we'll find some. Tech, big tech, little tech. Also, pick your tech, we'll find one. There are some serious gaps here, and there's incentive structures to fill those gaps. And I would say identifying how this is going to impact society, or where we have, human machine teaming for good versus not, right? Good luck. This is a huge, big space that no one is really paying attention to. Right now, it just sounds really good because it's like, oh, the killer robot is in the closet. We've banned it. Go away. It's human machine teaming, and therefore there's no problems. That is not, in fact, the case. There are a huge swath of problems that we have to understand. Everything from basic research all the way down to sustained military operations and sustainment and maintenance of these systems throughout their system life cycles. And with that, I'll shut up and I'll take your questions. Thank you so much.
Thanks very much, Heather. I don't know about the rest of the audience that tuned in for the presentation, but there's a few terms in there that I'm going to have to go and look up for my own benefit. But that's the difference between a doctor and me. I guess for trying to summarize what was a lot of information for us, I refer back to business experience and organizational design, where we look at people, processes, and systems. And one of my fears, especially in defense, where we are fascinated by technology and fascinated by the exquisite, we forget about all the other things and how it's going to actually come to life and deliver a capability. So an asset, by itself is not a capability, but all those things around it, how we grow, how we develop people, how we determine what mission sets to approve and how we execute that, contributes to that capability piece. And I think you've sort of hopefully not scared the horses, but certainly highlighted those areas that our Air Force, our Defence Force, and society as a whole really needs to understand as we see the growth of AI and HMT through different parts of our society. You coughed and referred to the Teslas and the smart cars, but that's just another example of HMT really in everyday life. So. I'd invite everybody to add your questions if you've got them for Heather. Oh, we seem to have dropped her feed for some reason. Are you still on with us, Heather? Well, that's unfortunate. We'll see if she comes back into the system. Not sure. At least we got through the presentation. We do have a question from Jody that we'll pitch out there. It's what would be some good resources to learn more about HMT. We'll see what if Heather can. Oh, she's just come back in.
Sorry, I don't know what happened. Can you hear me?
Okay, we've got you back. I think when you closed down there,
I was like, see, technology never does what you want it to.
Yep. Yeah, it's a learning journey every time we do these webinars. Heather, we've got a question from Jody. What would be some good resources for people to learn more about HMT? She found it fascinating, the breadth and depth of your conversation.
Oh, great. Well, thanks, Jody. So, I mean, there's a few. It depends on where you want to go. A lot of the literature either is really, really cursory and it just assumes like this is great, or it gets really, really technical really quick. I found one of the best papers on a big problem that I see by the name of, I'm trying to find it, it's Damtarla et al. If you send Theron an email, I can send you some citations. Damtarla et al, and it's like 16 different authors, but they did a really good survey of kind of existing benchmarks and metrics within the HMT space. Basically what they found is they ain't none. There's no common benchmarks, there's no good metrics. And so that one's really helpful. The Office of Research and Engineering at the U.S. Department of Defense also did a workshop about a year and a half ago, where they laid out some challenge areas for HMT going forward, and that document's also, I think, quite helpful. If you just Google DoD R&E human machine teaming workshop report, that should pop up. I think it's Frank Laird was leading that, LAIRD. And the Joint Concept Note 18, which I also noted, the UK's position, that one, it shows you kind of how shallow some of the thing, it goes more again to some of the platitudes, it talks to some of the difficulties coming forward, but it also doesn't really delve into anything substantively. But there's a few documents out there that, you know, you don't have to spend your life like me going gray and reading all of this stuff. But I can send you those citations if you like.
Yeah, I think that might be good if you can share some of that stuff. And what we'll try and do is when we load this video capture onto the ASBC website, we'll include some of those links. And outside of even your conversation, I think it's an important area that ASBC can contribute to that broader awareness and education for.
Well, and I would be totally remiss not to say that General Mick Ryan wrote an entire CBSA report on human machine teaming. So congrats to Mick too. You know, I was like, if I don't give a shout out to Mick, he's gonna kill me. So he has a good paper on this as well, and he does a really good job in his paper too, where he's talking more at the widget level, but he does start to identify some of these different types of dynamics and the relations between the human and the machine element.
Yeah. Okay. Well, we'll drag that out. I think we know Mick Ryan. He's associated with us somehow. Yeah. Okay. Another question. Chris has come in, says, and I'll read this because it's quite a long question, so I'll just read it. Military organizations certify teams. What is the discussion in the academic community around measuring and certifying human machine teams where the machines are learning along the way? For example, would a HMT learning machines then only be certified to use those specific machines that took part in the learning, or could they cross-load that learning to other machines and then use those? So it's really only, or is it really only the humans being certified? So
yeah, so
a little bit of a slippery slope, it seems like there.
It is. And so so I'll go back to my discussion earlier about how we certify teams now, right? Like when we think about not just, you know, we're not just looking at squads, or we're not looking at, you know, like Navy SEALs and Rangers and things like this, but because they're all individually qualified, and then they train as a team, and then we say, yes, you're performing well. And we constantly measure human team performance based on how much they sleep, and if they got, you know, what their PT tests look like and all that stuff. And for pilots, right, how many flight hours you have and all of this stuff. And you've got certifications on different aircraft, and you can do these things. But when it comes to things that are like human, non-human teams, so like the animal handlers relationships, in those instances, so in a previous life, I used to train dolphins for the US Navy. And that's how, and sea lions, yay! And so I was a civilian though, so, you know, don't hold me responsible for anything. But, you know, the way in which we do kind of certification with that is that these animals and these handlers are out every single day doing, you know, practices, and then when those animals are deployed, right, you know, you go through certain steps so that you say, like, are you really performing well? And their superiors are going to be doing evaluation on the handlers individually, and then on the animal individually with different handlers, and then on the team as they see it, as they go out and they function together. And that's how they kind of certify them, right? And they have these performance standards and metrics of what they're supposed to do and be able to accomplish in certain time boundary things, right? Accuracy, things like that. And so that's one way in which we get around it now, but that's very labor intensive, right? It is not something that is done at scale. I mean, there's a reason why we don't have like 1 billion dolphins doing mine, you know, EOD missions and mine countermeasures. And so, which is why we want drones to do it. And they're still working on it. But, you know, so that's one very labor intensive activity. And so when we start talking about doing human machine teams, right, I really can't get my head around how you can certify such systems at scale that isn't going to be labor intensive. There has to be, you know, it becomes that kind of recursive problem that the question started to allude to, right? Like, well, if I'm an adaptive machine and I'm adapting to the environment, I'm adapting to my people around me, what happens when some new guy comes in, right? Throws the balance off, because these systems don't perceive like humans. They pick up different features for wide and wild reasons. And so something new might really kind of skew the distributions in one way or another. And so how you find it, how you evaluate it, how you train with it, how you test with it, how you certify it, all of these are huge questions that no one has any answers to, not in the military and not in academics. And in fact, there's a big discussion just around how you certify autonomous systems, not even teams, right? But just the hardware and the software on it. And there is no good certification or licensure models that are being put forward right now. So these are huge challenges in the civilian space, let alone when you're trying to then put them in the military space. And you're talking about this as some sort of different version than mere interaction, right? That a human should just pop their head up now and again and look down.
That sounds like a massive challenge. And I'll do the unashamed plug, of course, that ASPC supports a range of different PhD and master's level fellowships, and it sounds like there could be a very good course of research in pulling apart that issue that you spoke of. One of the things that we're sort of playing with for an event later on in the year is this idea, and it's probably a little bit outside of your field of expertise, but around delivering mass through asymmetric opportunities. So, putting the exquisite capabilities aside and using something a little bit different, a little bit cheaper.
Low cost attritable systems, and we
so
a la World War I. Yay!
Everything old is new again. But one of the things that occurred to me when we were sort of looking at this as a conference theme was how established is the organization to actually operate those systems? Because it's no good having an agile delivery or effect capability if the processes and systems that sit behind it are still operating on the old model. How are you seeing that sort of stuff play out in the US and broadly across academia? Or is that too big a question?
No, I mean, I think, look, I'm constantly surprised and not surprised. Like, once you start working within a large bureaucracy, you start to see how hard it is to turn the bureaucracy and the culture of the bureaucracy around, right? And so, not because I think that it's a sinking ship, but I feel like the analogy is a good one, right? Sometimes the DoD's like the Titanic, right? You see the iceberg, you're like, move the ship. But it's just so big to get it to really move and function is not an easy thing to do. And so I think when it comes to, changing the mindsets of how you utilize these systems with existing ConOps, with existing ConEps, with existing strategic cultures, with existing organizational cultures, and the incentive structures of different generations within those cultures, things are going to be painful for a while, right? So you have the one problem of legacy hardware and software, and you're going to be incorporating this stuff with legacy systems. So interoperability is going to be a problem. That's a technical problem, right? That's not a people problem. And I think a lot of this has to do with people problems. We don't want to focus on the people. It's just too hard. It's just too messy. But that's fundamentally what most of this is, right? We're trying to create technology to enhance or to make superior humans in warfare because we don't think that wars should be fair or symmetric. We want to have superior power so that we don't have to fight them. We can deter them or we can win them, period. But those assumptions fail to think about, okay, well, if I say that I want to have human machine teaming, and it doesn't have to be loyal wingman, but it could be exoskeletons and massive swarms and neural interfaces, and it can be all these different things. We can even talk about the fact that there may be another Venn diagram with human machine teaming and human enhancement, right? And so there's so much here to unpack. And then once you're placing it in an organizational structure that fundamentally hasn't changed in over 100 years, that's a big problem, right? How we even divide up. So for the Air Force, for instance, every Air Force, every joint operation that the Australians do with the United States, with, NATO forces, like every single Five Eyes, like we divide airspace. You're from here, I'm from here. We deconflict, right? But don't come in my corridor because I might shoot you down. And so, doing just even getting IFF right on legacy systems is sometimes hard because we've had Patriot missile problems in the past. Sorry, Brits, right? Like these are fundamental problems because the way in which the organizations train and enculturate and put their tech out is more rigid than the tech itself. And that's a much harder problem to fix.
Yeah, I agree. We've had a couple of extra questions come in if you've still got a couple of minutes time.
Yep.
Michael has asked, what is the boundary between HMT machines and autonomous machines that the human sets loose? So, I guess, is it human on the loop, in the loop, or completely outside the loop? How does that all work?
I hate the loop. I hate the loop. The loop needs to die.
Fair enough.
It's a bad construct too. It's lazy thinking. So, and Boyd, by the way, never wrote down anything. He was a PowerPoint junkie that needed to go someplace else.
Sounds like another discussion.
Exactly, but I digress. So I think the distinction, but that's the problem, right? That's the whole point of the talk, is that there's no really good distinctions right now about what constitutes an HMT versus what setting an autonomous system loose is, because, I'll give you an example. The French, for instance, in their definition of autonomous systems, they just put out some recent literature on what their position is on autonomy. And it's a unicorn position, right? It's a magical creature that doesn't exist. No modern military would create a system that it can't control, that launches itself, that has no communications, right? Like, what commander would want to do that? No, you want to have knowledge of your adversary, where there's potential for collateral harm, what the tempo is, what the effects are going to be, whether it's legal, right? What are the backup plans, right? What are the tasking orders and the interoperability and who's doing what? And here's the synchronization, right? There's so much planning that goes into an operation. And so to just be like, yeah, whatever, send it out. I don't know what it's going to do. Like, no, right? Like we don't even you couldn't even build a system to do that today, given requirements and verification and validation. And so, and safety testing and everything else, right? Because there has to be safety for our people, not just civilians and others. And so in that respect, the French have created the definition of a system that will never exist. And they say they'll never build that system. Well, great, but you've defined yourself out of the problem. Now you use definitions as a political weapon, right? And so you said, look, I'm so great. I'm never going to do this. You're like, well, then everything short of that is permitted. But now you've kicked the can. And this is the same thing about human machine teams, right? If you make the definition either so kind of unicorny with magical rainbows that it will never exist, well, then there'll never be a human machine team. But if you make it so inclusive to include so many other things, then everything becomes human machine teaming. And then you say, well, there is no autonomy, it's all teaming, right? But then how do you discuss this team versus that team, this level versus another level? Then all of a sudden they become these kind of arbitrariness. And I mean arbitrariness very much truthfully in the definition of arbitrary, right? You look at Sheridan and Verplank and their levels of autonomy that they created, in the 70s. And the only real difference between level 1 and level 10 is someone turns it on and someone doesn't. All the ones in between are so there's it's so that you can have 10 levels of autonomy, and there's actually no fundamental difference except between 1 and 10. And so when you think about that, you're like, oh, well, then I don't really know what to include in HMT because no one's helping me. And there's a political incentive to not make that definition very good, as the French have shown. And there's also technical considerations of I don't know what to include. Maybe it's so general that lots of stuff can be there, but it's a problem that we have to grapple with and not just be like, it's great.
So are there industry agreed definitions at all? Is there anything that we can grab hold of and use? Is it, state by state type of approach? So, or is this completely greenfield?
I think it's greenfield in academia right now, right? It's greenfield in academia. And I think it's greenfield in the military space, which is why you see a key indicator that it's greenfield is because the terms keep shifting, right? You go back to 2014 or 2015, we talked about centaur warfighting. Remember that? Right? Paul Shari and Bob Work. Oh, the third offset strategy. It's centaur warfighting, just like centaur chess, right? Humans and computers playing chess together. Great, bigger chess. Yay. Okay. Well, it went from kind of centaur warfighting and then human machine teaming to then manned unmanned teaming to now human autonomy teaming, right? The terms keep turning over. And I think a sign of that is that there's no norm about what it is. So there's no kind of cascade of scholars saying this is important and these are things that matter, right? Everybody's still kind of vying for what that thing is. And so where you do see discussions is like on the edge, right? You see discussions about trust, or you see discussions about bias, or you see discussions around explainable AI and transparency. But that's assuming you've already figured out all this back end that you clearly haven't.
Yeah. Okay. Who we got here? Julian has asked a question. He expresses the same reservations that you've articulated today. In terms of analogies, do you feel the human-tool analogy is exhausted, or the extended body/mind analogy has been given enough emphasis?
Sorry, my daughter just came in and plopped something on the desk, so I was like, the tool versus teammate kind of question.
Yeah, his terminology is human-tool analogy versus the body/mind analogy.
Oh, I see. Yeah, I mean, I don't know if either one of them are exactly right. You know what I mean? Like we can use cognitive entities now as tools that have minds. So back to the animal thing, right? Like I use my dog as a protective tool. I have a 90-pound male German Shepherd who is a lovable little man, but not little. But, when I go running, people are scared of him, and that was the point. And so, but in that sense, it's an instrumental good, right? It gets into that teaming, instrumental, cooperative symbiote. And so, but he's got a mind, he could decide to bolt off. And so, so the human tool thing kind of gets around, like there's other non-human things that we could have human, non-human, carbon-based, silicon-based, right? We could start to make these divisions, and I'm not quite certain. I don't know the justification for doing that just yet. And then on the tool versus teammate thing, well, man, people use other people as tools all the time. And so I think in that respect, that's also a false choice. And then the mind body thing, like that's been debunked for a long time, right? Like, I mean, the Cartesian dualism needs to be dead with Descartes. Like, even in the medical field, I mean, the medical field still does this whole mind body thing. Like, oh, you got a mind problem? Go see a psychologist. Oh, you got rheumatoid arthritis? Come see me. But even in the human mind, right? Psychologists, neuroscientists, neuropsychologists, they basically say, look, like the way in which your mind functions is part and parcel of how your body's functioning. And so there is no mind body distinction in the ways in which we've thought in the past. And so that also is a problem. And so, but then how we're bringing in these entities, we'll just say that, is a challenge. But even if we make those commitments, we say, no, I'm going to throw the stake down here. This is what I'm going to include. This is what I'm going to exclude. These are the reasons why. Like that would be a good start. Like,
yeah.
Be explicit in your terms, explain what the assumptions you're making and why, and then why you're not going and doing something else, right?
Yeah.
And that's just good science. That's good practice. And we need to start doing it and not, think that because it's like, oh, so sexy and like, ooh, widget hardware. ooh, AI, it's going to solve everything, right? No, we have to start being much more methodical in how we do these things and make our justifications and assumptions known.
Yeah, and if I jump back to my sort of the cognitive edge training that I did a couple of years ago and looking at complex systems, I think we're still very much in this is a complex system, and the more we try and have analogies or models, it's our attempt to try and simplify that so that we know what the cause and effect is. Whereas we don't yet. We're still in that, probe, find out what the result of that probe was, and then go, oh, okay, that's what happens. So
Right.
that's the definition of complex system.
And complex systems are by definition adaptive, right? And so once you have a complex adaptive system, different perturbations in different areas at different times create different effects. And the incentive structures of like positive attractors and negative attractors. I love complexity theory, and like get me on complexity theory and complex systems anytime. But like, there's so many different elements to that you have to think about feedback loops in those systems. And because we're not thinking of it in this, like, you can't just hold one thing constant, like, oh, it's under a hood and I'm going to look at 4 variables and I'm going to hold these constant and then put the, like, we can't do science that way in this world, especially as we're pretty much beta testing these types of demos and prototypes in the real world on real people. And then being like, yep, that holds all the time. And you're like, no, it doesn't. So yeah. I'm totally with you there, Theron. Totally.
Cool. I've got to get to this question just because Reg Carruthers is an old commanding officer of mine. So Reg, if you're still online, hopefully you are. I hope you're doing well. He's asked, we've covered the the human machine teaming concept in a defense environment. Are there any other sectors that are working on these challenges? And he's used space or remote mining operations that might provide different approaches or different solutions as well.
Yeah, I mean, I think that there space definitely, but space to date has been struggling with a different set of challenges, not so much on the human teaming side, given time delays and lags, and and just environmental challenges as well. And so, yeah, we definitely have it in space, but it has a different tempo. And so I think in that respect, yeah, that's a different that would be a conversation for a skiff.
Gotcha. Understood.
And so, yeah, so I would say, that is one area. It's interesting to see what the civilian side of space is doing with SpaceX and, Blue Horizons and all that stuff. But still, those are just kind of right now, like, really cool things, but like, I'm not seeing a lot of teaming, unless we, again, say any interaction is a team. Yeah. So, and then in the mining stuff, yeah, like DARPA's been doing some interesting stuff on autonomy, for mine exploration underground stuff, which would have some interesting teaming implications for then, like, okay, well, we can't send a human down there because of X. So then once we have the system come back and how the human interacts with it, what do we do, right? And that would be teaming in the sense of, like, it would be a handoff, right? Mm-hmm. Much like how, a quarterback throws a ball and a running back catches it, right? Like, it's not, they're on a team, they're just doing things in different sequences and different tempos. So, but those are, again, types of qualities that we want to understand. And we might just want to say, look, I don't even have to talk to my teammates using natural language. Maybe it's gestures, maybe it's signals, right? User interface design becomes really important. Colors, widgets, buttons, icons, VR, AR, like all of that stuff becomes really important, especially if you say, look, what we really need are we need these, machines over here, and we need a human over here, and they're virtually, they're virtually in the same space because the human is using AR or VR to complete the whatever mission or thing.
Yep.
Oil drilling on a rig, whatever. Right. But then it's mediated through another layer of technology. So there's all sorts of, like, really difficult questions, but you can endlessly take up time.
Right. Noting it is 23 minutes past 11 our time. It's probably dinner time in your location.
It is. It is. It is. I am going to go get a glass of Prosecco and I'm going to have some steak. My father is cooking steak.
Lucky you. We've got, I guess, one last one. Luke Watts has come in. What are the consequences if we fail to provide policy and language around the HMT relationship?
It's just going to get worse. I mean, honestly, like, Luke, if you ever want to just kill yourself, go to Geneva and sit and listen to some of the stuff. I mean, honestly, like, and it's just the quality of the debate about what we actually mean and need at the international stage is so poor so often. And sometimes that's for dissembling reasons, and sometimes it's just for because, you know, people are so busy that they can't know everything all the time. But like, really, I think the impact of that is that we are going to we're going to have greater weird fights with adversarial nations. The second is that we're really not going to understand our allies very well, right? Everybody's got to come to the table knowing what the heck they're talking about. And so then when we do interoperability, we do joint training, we do buy kit from other countries, all of these things have to be made transparent so that we know the data, the certification, the licensures, off-label use, on-label use, what you mean by team, what you mean by interaction, right? The practical realities of actually accomplishing a mission, then those start to matter big time. Unless we're talking at cross purposes, it's not going to work.
Yeah, that complexity becomes unmanageable then, doesn't it? And
it does.
Mistakes happen. Yeah. Look, thank you so much for your time for the last hour and a half or so. Really appreciate the time coming into us from the USA. It's a really big thing for us to hear from somebody of your stature, and also to throw out those challenging concepts and make us think about more than just the toys we want to build or buy, and how it's going to actually be applied. So
yeah, I care about the people.
Yeah, I'm a personnel capability officer by trade, so yeah, people are my bent as well. On behalf of the director of the Air and Space Power Centre, thank you very much for contributing your time and thoughts, and we hope to stay in touch through different means.
Definitely. Thank you so much. And if anybody has questions, please don't hesitate to reach out, and I'll try to be as helpful as I can.
All right. And for those still listening or watching the video, next month we'll be talking to the Jericho team to find out what new, innovative and disruptive ideas they're coming up with. And you can check out this video on the ASPC website in due course. Thanks, everybody, and we'll see you next month.